Well, welcome to a question a day, day 22 of extension 2. Look, this question, I just had a quick look at it. It's about e to the x expansion. So I just wanted to quickly, before I get into the question, talk about where on earth this comes from. This e to the x equals 1 plus x on 1 fact plus x2 on 2 fact plus x cubed on 3 fact and so on. And it comes from where someone has tried to find a function that's a derivative of itself. Now, if your original function is 0 and you find the derivative, you get 0, so you win. You found a function that's a derivative of itself, right? But let's get something a little bit less trivial. So what about if we start off with the function being 1, right? What's the derivative of it? Oh, 0. Oh, if I wanted the derivative to actually be 1, so the derivative of the function is actually equal to the original function, right? What am I going to have to put up in the original function? And of course, I'm going to have to put an x up there, right? Now, that derivative is correct. The derivative of 1 plus x is 0 plus 1. Only problem is my original function and my derived function aren't the same function. Oh, well, if I want to have a plus x down here, I'm going to have to fix that up by putting plus half x squared there. Now, it's true, the differentiation aspect is true. The derivative is the derivative of the original function. But now the original and the derivative function aren't equal. But I can make them equal by adding on a half x squared. Now they're equal, only the derivative is not the derivative of the original. In order to make it the derivative of the original, I need to have 1 on 3 times 2 x cubed. But now the two functions, like the derivative side of things is correct, but the two functions aren't equal. So I make the two functions equal by putting 1 3 times 2 x cubed on the bottom, but now the derivative aspect's not correct. So I make the derivative aspect correct by, popping 1 on 4 times 3 times 2x4 there. Now the derivative aspect is correct, but the two aren't equal. So I need to add this on. Now if I keep doing this infinitely, right, if I now add on the next one up on the top line and add on the next one down on the bottom line and so on, if I keep going ding, 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 adding, really quickly to infinity, the two functions will correctly be the derivative will be correctly the derivative of the original, and the two functions will actually be equal to each other. So this original function up here is the same as its derivative if you go out to infinity. The original function is the same as its derivative if you go to infinity. But we know from our other work, e to the x is the derivative of itself, and it's the only function. So that means that this e to the x must be the same as this 1 plus x plus a half x squared, which is that, plus 1 on 3 times 2, which is actually x cubed on 3 fac, plus x4 on 4 fac, plus x5 on 5 fac, and forever. We know they're equal because e to the x is the derivative of itself, and that function on the right is the derivative of itself if you go to infinity. So intuitively, that's where that comes from. All right, what's this question wanting? Well, they're wanting to use that expansion to do some stuff here. They're saying, first of all, by using e to the ix equals cos x plus I sine x, write down the first 4 terms in each of the expansions of sine x and cos x. So instead of x up here, right, I'm going to put ix in. Wherever I see an x, I'm going to pop an ix, right? So e to the ix is equal to 1 plus ix plus ix squared on 2 fac plus
ix cubed on 3 fact plus ix4 on 4 fact plus, all right? So
let's keep going. Plus ix 5 on 5 fact plus ix6 on 6 fact plus ix7 on 7 fact. There we go. So this is meant to be cos x plus I sine x, we said, on the left-hand side, and it's equal to, now I'm going to get all the real parts together, 1 and minus x squared on 2 fact, and x4 on 4 fact, and minus x6 on 6 fact. I've only expanded the first 8 terms there, and there's the first 4 real ones. And the first 4 imaginary ones are ix and minus x cubed on 3 fact, and so you take I out of there, you've got I to the 4, which is plus x to the 5 fact, and minus x to the 7 on 7 fact, and it keeps going, but that's the first 4. So you can see by equating the real and imaginary parts, what we're going to get. We're going to get that cos x is equal to 1 minus x squared on 2 fact plus x4 on 4 fact minus x6 on 6 fact, and so on. And sine x is going to be x minus x cubed on 3 fact plus x5 on 5 fact minus x7 on 7 fact, and so on. All right. Now the next question wants us, is that what they asked for us to do? Yeah, first 4 terms in each of the expansions of sine x and cos x. Find the expansions of e dx cos x for powers of x that are less than 4. I meant less than 5. I meant equal to 4, right? Up to 4. So let's go down onto the next page to do that. Find the expansion of e to the x cos x, right? So just e to the x cos x is equal to the original expansion they gave me, 1 plus x plus x squared on 2 fact plus x cubed on 3 fact plus x4 on 4 fact, right? Plus times cos x, which we just got the first 4 terms of, which is 1 minus x squared on 2 fact plus x4 on 4 fact minus x6 on 6 fact, right? And it goes on forever, but if I just cared about the first few terms. Now they want that like up to x to the power of 4, anything that will times out to be up to x to the power of 4. So this term that I put at the end of here, irrelevant, it's going to not be helpful. But the others are all possible. We can ignore some of the multiplications, but we'll have to do some of them as well. So I'm going to expand these brackets. The 1, first of all, I'll do this here. This 1 has to times all these. So I'll get 1 minus x squared on 2 fact and plus x4 on 4 fact. Now, the next thing is that the x, this guy, only needs to times both of those, because if it times with the x to the 4 on 4 fact, we'd get a power greater than 5 or more, right? So the x times is with the 1, and the x times is with the x squared on 2 fact, and that's it. And then finally, when I'm looking just for those powers, let's get a green one. This guy's x squared, so it can times with the first and the second one as well, and make it into powers up to 4, right? Equine with both of those. So I get plus x squared on 2 fact, and I get minus x to the 4 on 2 fact times 2 fact. That's on 4, isn't it? Is that right? Not on 4 fact, but on 4. Yeah. So that's the expansion I get. I might just simplify that down without the factorials. I get 1 minus x squared on 2 plus x to the 4 on 24 plus x minus x cubed on 2 plus x squared on 2 minus x4 on 4. All right. Why are we trying to do this? Because we're going to be integrating that. So why don't I gather it together and get the actual powers now. So there's a 1, and then the x's, there's just plus an x. And the x squared, there's minus x squared on 2 plus x squared on 2. So that's cancelled. The x cubed, there's minus x cubed on 2. And the x4s, there's x4 on 24. So, and then there's minus 6x4 on 24. So there's a minus 5x4 on 24. All right, so that's got that written out a little bit neatly. So I can use that because they want me to integrate that. They want me to go the integral from 0 to 0.1 of e to the x cos x dx. And I'm saying that'll be the same as the integral from 0 to 0.1 of this thing I've just found. 1 plus x minus x cubed on 2. I'll just write it down. 1 plus x minus x cubed on 2. And the last term, minus 5x4 on 24. Dx. Now that just if they care about those terms, and I guess because I only want the answer to 3 decimal places, if you power up 0.1 to anything more than x to the 4, it's not going to be relevant. Even x to the 4, it's going to be not affecting those places probably. So that's why they've only rounded it like that. All right. So the integral of 1 is x. The integral of x is half x squared. The integral of x cubed on 2 is x to the 4. Now that will be on 8 because that'll be a minus x cubed on 2. And the integral of 5x4 on 24, we've got x to the 5, and that'll give you 5x to the 4. So we just want to be on 24, minus 5x4 on 24. And we want from 0 to 0.1. So that's equal to, and then we've got our 0.1 plus a half times 0.1 squared minus 0.1 to the 4 on 8 minus 0.1 to the 5 on 24. And then it'll be minus 0 and 0 minus 0 minus 0. All right. So it's just 0.1 plus a half of whatever 0.1 squared is minus an eighth of whatever 0.1 to the 4 is minus a 24th of whatever 0.1 to the 5 is. Now, if you look at 0.1 to the power of 4, you get 0.0001, right? I'll just point something out here. This here is 0.0001. If I'm only caring about 3 decimal places, that may or may not affect it, depending on whether I multiply that by a number big enough to affect it. This term here certainly has no effect because this 0.1 to the power of 5 is 0.00001, and unless I multiply that by a largish number, I'm not going to get that out of the 5th decimal place, so it's hardly going to affect me doing anything to 3 decimal places. And I'm not multiplying it by a large number, I'm multiplying it by 1 on 24. So that, I don't even need to take that one into account if I don't want to. And really, I probably could get away with that third one not affecting anything. However, it's not a big deal to throw all those numbers into the calculator. So 0.1, I'll just change modes on the calculator here. I'm in statistics mode. 0.1 plus 1/2 times 0.1 squared minus 1 on 8 times 0.1 to the power of 4. And then I'm just going to add it on anyway, even though I know it's not going to have effect, minus 1 on 24 times 0.1 to the power of 5. And I get 0.1049870,833, right? And I've been asked to do it to 3 decimal places, so it's 0.105. Now, this bit, it's hardly accurate, this number here, because already I've only considered the first 4 terms in each of the expansions, right? So writing down a big long decimal like that's a bit irrelevant, but I'm trying to just show you, I wrote that out of the calculator for those 4. But had I just considered the first couple of terms, I would have got 0.1 plus 0.5 times 0.1 squared. I would have got 0.105. Like I was saying, you know, I really only need to consider those 2 because the other terms aren't really going to impact them. All right, whatever the case, my answer to that is that it's 0.105. Now, they're asking me to, instead of using the series and just the terms I need from the series, they're saying, why don't you do it by actual integration and see what your answer is to 3 decimal places, and hopefully it's the same. So I'm going to do it by actual integration. Now, remember the old Liati? We've got an algebraic expression. No, we've got a trig expression. We don't have an algebraic expression. Let's get rid of that. We have a trig expression, which is our cos x, and we've got an exponential expression. Now, the cos x comes first, so u is cos x. So let u equal cos x, right? So du dx equals minus sine x. And therefore, dv dx is equal to e to the x, because one of them gets to be u and one gets to be dv dx. That's how this thing works. And Liati tells me that use the cos x as u, so the e to the x is dv dx. If I integrate that, right, so that's my setup. Now I'll just write down my rule with a different coloured pen for you. The rule I'm using is that the integral of u dv dx is equal to uv minus the integral of v du dx. That's basically the integration by parts, just written in quick form. So let's put these numbers into here. So the integral of u dv dx, which is the integral of cos x and timesing e to the x. And yes, there's dx's there, but let's throw it in, is equal to uv, so cos x times e to the x. Now that's a done deal. You don't need to integrate that. That's uv, but you need to do minus this integral, the integral of v times du dx, which is minus sine x dx. All right. So far, we've got down to that point where I'm going to fix it up. The integral of cos x e to the x dx is equal to cos x e to the x And this was from 0 to 0.1. So that goes from 0 to 0.1 plus integral of, and now we've got sine x e to the x dx. And I'm going to have to do an integration by parts within an integration by parts. So let's go a different coloured pen. Let's go a green. And I'm going to just take on this guy here. And for this, I'm going to let u be sine x and dv dx be e to the x, using Liati again. So du dx is equal to cos x, and dv dx, v is equal to e to the x. So using the rule that's written in red above, but just doing this sine x e to the x from it, I get uv, which is sine x times e to the x, minus the integral of v du dx. All right, so just I'll write down in one big long row what I've got so far. I've got that the integral from 0 to 0.1 of cos x e to the x dx is equal to cos x e to the x from 0 to 0.1 plus sine x e to the x from 0 to 0.1 minus the integral from 0 to 0.1 of e to the x cos x dx. That's what I've got by doing a integration by parts within an integration by parts. So this is like cos x e to the x plus sine x e to the x from 0 to 0.1 minus from 0 to 0.1 e to the x cos x dx. And that's equal to that. All right. Now, you can see that this guy here is the same as this guy here. So if I add, plus this guy onto both sides, because there's a minus involved there, if I pass that on both sides, I'll actually get two lots of this guy over here, equaling, and then it's this guy e to the x into cos x plus sine x from 0 to 0.1. So that means the original one, I just divide by 2 and work out this definite integral here, and I'll have my answer. So that's equal to a half. Okay, now we've got e to the 0.1 cos of 0.1 plus sine of 0.1. Hey, that's in radians, of course, because it's calculus, right? So that's that minus e to the 0 cos of 0 plus sine of 0. Remember to put your calculator into radians when you do that. So mode, what's going on with this calculator? Shift mode 4 on this one. And I go e to the 0.1 times cos of 0.1 plus sine of 0.1 equals minus, now e to the 0 is 1, sine of 0 is 0, so this is just minus 1. It's that, and then times that all by 0.5. And I'll get 0.10499132788, which is a bit more accurate than what I had before, because it's using all the terms, not just the first few terms. But the question actually asks me to using that to find it correct to 3 decimal places. So the answer, as before, is 0.105 to 3 decimal places. So how do you like that? We got 0.105 for the other one as well. And turns out that when I said I thought I meant up to x to the 4 there, rather than, so less than 5, like I've changed that when I've been doing this, probably if I'd just gone up to x cubed, I would have been fine, wouldn't I? So I would have been able to just do the question as it stands, and it would have all worked out just nicely. So you get the point of how to do it, that's the main thing.